Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad RAZIN bin AMRAN and my group member name is Aiman bin Muhammad. So we are going to explain about thermodynamic assignment. So this is the question and we have to sketch the process on a TS diagram and determine the air temperature at the turbine Z, the network output and the thermal efficiency. So this is the TS diagram that we have sketched and this is the answer of question A. So first we have to find the T2S diagram using the formula T2S over T1 equal to P2 over P1 the power of K minus 1 divided by K. So we put the value in this formula and we get the T2S is 540.528 K. So next we have to find the T2A using the uh, formula of compressor efficiency, which is T2S minus T1 over T2A minus T1. So we put the value and we get the T2A is 617.3707 Kelvin. And after that, we have to find the T4S using the same formula we use to find the T2S, which is the T3 over T4S minus by the ratio pressure, the pressure ratio, power of K minus 1 divided by K. So we put the value and we get the T4S is 659.54 Kelvin. So lastly, we have to find the T4A using the turbine efficiency, which is T3 minus T4A equal to T3 minus over T3 minus T4S. So we put the value in this formula and we get the T4A is 747.8228 Kelvin. Okay, next one this is the answer of the question B, that we have to determine the network output. So the constant pressure is 1.005. We use the formula W net equal to Q in minus Q out. So we expand the formula constant pressure T3 minus T2A minus constant pressure T4 minus T1. So we put the value in the formula and we get the network output is 95.2805. So for the question C, we have to find the thermal efficiency. The thermal efficiency, the formula is 1 minus T4A minus T1 over T3 minus T2A. So we put the value into the formula and we get the thermal efficiency is 0.178 or 17.8%. This is the TS diagram when effectiveness of regenerative is 65%. So this is the TS diagram. So this is the uh,
For the next question, I will answer about the comparison before and after using the regenerative system. So here we can see that before the regenerative system is applied, the thermal efficiency is 17.8%, and after the regenerative system is applied, the thermal efficiency is going up to 21.28%. And for next, I will brief a bit about thermal cycle efficiency. Modern combined cycle gas turbine (CCGT) plants, in which the thermodynamic cycle consists of two power plant cycles. Example, the Brayton cycle and Rankine cycle can achieve a thermal efficiency of around 55%. In contrast to a single cycle steam power plant, which is limited to efficiencies of around 35 to 45%. For the next question is impact on the overall thermal cycle efficiency. The Brayton cycle thermal efficiency increases with both the turbine inlet temperature T3 and compressor pressure ratio R. Modern gas turbines have pressure ratios as high as 30 to 1 and turbine inlet temperatures approaching 3000 Fahrenheit, which equal to 1649 degrees. Next, I will explain about the next question, which the benefits to the environment when the operationer decided to install the regenerative concept. The first benefit is it will enhance brand image and increase competitive advantage. Next, it can make better financial investment opportunities. The third one is it will increase preparedness for future legislation and costs. And lastly, it will increase productivity and reduce costs. That's all for our explanation video. Thank you.